In this series of videos I'm attempting to repair and restore this Osborne OCC1 vintage computer. In the previous video I got as far as going through the floppy drives. I don't know if they work yet, but I cleaned them mechanically, got rid of corrosion, freed up the heads, and in theory at least they should be able to move the various mechanical parts, but I don't know if the electronics work. I then plugged everything together and tried to boot, and it won't boot up. I do have a floppy disk in the boot drive. It's not a boot disk, but the system won't know that until it tries to read it, but it's not getting as far as that. And what we can do now is start trying to fault find the machine. It's quite difficult on this because of the way that there's a daughter board directly above the main board. If we turn this over, we can't get direct access to some of the parts. There's an option board fitted to this. In fact, there are two option boards fitted on this particular machine. What we did when we found it wouldn't boot up, so what it's doing is putting a message on the screen saying insert the disk and press the return key, but when we press the return key nothing happens. I tried jumpering the relevant pins on the keyboard connector, went through the keyboard interface components, just the ones that are directly connected to the socket, and found that that seems to be working. It seems to be able to see actual key press inputs. So what we can do now is start trying to figure out what's going on, go into the electronics and see if we can get this to actually work. So step one is to see what the machine is actually doing. I've plugged the keyboard back in, and I'm going to boot this up now, and we'll see what response we get from the display. So what's going to be quite difficult to explain here is the display will flicker under certain conditions. So if it's busy doing something, then the display will rapidly switch on and off. Unfortunately, it seems to be doing that all the time through the camera because of the shutter speed of the camera tends to make it look that way anyway. And also the camera I use has variable shutter speed and frame rates. So it's quite difficult trying to describe exactly what I'm seeing because you're not seeing exactly the same thing that I am. But we'll try and go through this, and hopefully I should be able to explain what we're looking at. But the main thing to bear in mind is that on these machines, when they're trying to do certain things, the display is blanked, and it will cause the display to appear to flicker in real life if it's trying to do something and it's failing. One thing that's nice with these machines is that the BIOS listing is available in the technical documentation, so if you want to see exactly what it's supposed to be doing, that's quite a nice thing to browse through. What I'd really like to be able to do is attach a logic analyzer to the CPU, and what we can do then is kind of walk our way through the code in the BIOS and see what's going on. We can do that, we need to flip the board the other way up, but the connections to the CPU are available on the top of the daughter board, so if we want to do that we can. We just can't get to all the components on the underside while we're doing that, because the board will be upside down of course. But before we get that far, what I want to do is just demonstrate a few things, and it will give us some indications and some clues as to what we're actually looking for. So if we press the return key, notice that nothing appears to happen. But if I now press and it's booted up of course, it's upside down, but it doesn't really matter what it's saying, it's really the general response from the display that we're interested in. The reset key over here, that will cause the machine to jump to its reset vector, and then the BIOS code will start up from scratch. So when I press this, notice that the display, I don't know if you can actually see it, it's flickering, and then it does that for a few seconds and then it stops. I'm going to try turning one of the lab lights off, and hopefully the kind of background flickering that you're seeing will stop. So hopefully that stabilises the display a bit. I'll press the reset button again, and the display flickers for a short time and then stops. If I press and hold a key on the keyboard, so I've got one of the keys depressed, I'll press the reset key again. Notice the flickering continues until I release the key. So we'll do that to a different key, doesn't matter which key, do a different key. And this time it's stopped. I'll press a different key. And then release the key. And notice, so there is something going on. It is seeing key presses, and it is doing something in response to the key press, and that does seem to vary a little bit. Now I think one of the issues we've got here is, I believe that one of the keys that is being seen from the keyboard, it thinks there's a key down all the time. I'm not quite sure which one it is. We can go through, in fact I will now go through with the scope and try and figure out which key it thinks is depressed. And the way I'm going to do that is, as we tried in the previous, turn the light back on, in the previous video, this is the interface for the keyboard, and the way this works is there are some strobe lines that come out to energize each of the rows in the keyboard. There's nothing in the keyboard apart from switches, remember, and then depending on which key is pressed, the signal will come back round, the pull-up resistors will pull the line high, and when the output buffer chip is strobed, if a key is pressed, the system can work out which key it is. And we can do that in reverse. We can see which of these lines is being held low, and then we can go back and figure out from the key switch matrix which particular key or keys are being held low. So I'll do that now. I won't bore you with that. I'm just going to go through with the scope and see if any of these lines are tied while looking at the strobe lines. That will be pin 1 of this IC, and we'll see if at that strobe time whether any of the lines are actually low, and if any of the keys are pressed. So if I look at pin 1, and this is the UE12 IC, and I also look at, I've got the scope set up by the way so it triggers when both of these pins are low at the same time. So it's basically it's wired NAND. And you can see that the yellow trace is the strobe, that's pin 1 of the IC, and the top trace is low at the same time, and it shouldn't be. None of the keys are pressed on the keyboard. If I unplug the keyboard, then that signal goes away. If we look at a different key, for example, then notice there is no triggering because the two are never low at the same time, so the strobe's still occurring. It's never occurring when that line is low. And if we look at another one, same thing, we're not getting any triggering. If we go back to this one, we are seeing a constant signal, so that means that there's a key constantly held down, or at least they're short on the key line on that particular line. It's definitely from the keyboard. If I unplug the keyboard, that goes away. And that's pin 15 of this IC, and if we look around we see that pin 15 is here, and so that is column 4. What I can do now is see which line for the rows is active at the same time, and then I can look up in the table. So if we look in our table, we know it's one of these keys. So all I need to do now is look at the row and find which particular key is offending. I'm also going to take the keyboard apart, we'll have a look inside and see if we can figure out what's going on. Okay, I traced it through and it looked like the offending key was the T key, and that's in column 4, row 3. So I'm just confirming that. I've got the keyboard unplugged, I've got the multimeter set up in continuity mode, and I've got the yellow wire going into the connection for column 4, and what we want to do now is look for the offending row. And if we look at the schematic, we'll see that if we want to find, in fact we'll look back at the table, notice that the T is in row 3, the 0 base, so it's 0, 1, 2, 3, and row 3, if you look on the schematic, is this one, and that's pin 4. So looking back at the connector, one issue with these connectors is the end 2 pins on each end aren't used, so you start numbering from here. So this is pin 1, 2, 3, and this is pin 4. And as you can see, that is indeed where the short is. I don't have any keys pressed on the keyboard, can't get everything into the shot at the moment, but no keys are actually depressed, so we obviously have a fault with this keyboard. It doesn't explain why the machine won't boot up when I bypass this and try to boot with a jumper, but we'll get this sorted out first, and at least we can make more use of the keyboard. So we'll get the keyboard taken apart and see if we can figure out why there's a short on these 2 pins. As you can see, I've dismantled the keyboard, and unfortunately there is a short on the actual membrane itself. The short will go away if I disconnect the end flat flex cable, so there's a short underneath the switches somewhere on the actual membrane. But I may remove the key anyway, just to make sure there's nothing trapped in there. Could be a bit of swarf or something. But these are kind of heat welded in, there's kind of heat riveted in, so once you remove them they're difficult to refit, but as I said, the keyboard's likely not repairable anyway. It looks like there's been water spilt in this, so looking inside the tray at the bottom there's a lot of what appears to be debris from water ingress, so that could be also what's gone wrong within the keyboard. So unfortunately this may be put on hold for a while I try and figure out a solution for this. Of course without the keyboard it's not a lot of good. I'll take the key out and have a look at it, but I'm not really holding out much hope. I've got a feeling the short is somewhere on the membrane, which is a bit unusual, but it does sometimes happen. Well, as I didn't have much to lose with this, seeing as how the keyboard's not working, I decided to have a bit of a poke around with it. So I've removed the switch plunger. So this is just nothing more than a membrane switch, and the mechanical part is just a plunger on a spring, and it presses the center part of the membrane down. So these are just membrane switches in an array. But what I found is that if I manipulate this, I can get the reading on the meter to change. Initially it wasn't doing anything at all, it was just sitting there at 26 ohms, but the more I've played with this, the more it's started to go back up. So I've got a heat gun here, I'm just going to try something. Normally these membranes are kind of a material that in theory should return to its normal state if warmed up, as long as I don't go too far. So I'm going to try doing this, just gentle heating, and see if that has any impact on the reading on the meter. Okay, that's interesting, it's gone back up, and as it cools down it's coming back down again, so I'm going to heat it a bit further. If I can get it to stay domed up it might start working. I don't really hold out much hope for its long-term prospects, but I don't need it to last for a long time. If I can find a replacement, I do need it to work my way through the rest of the fault. So I'll heat and cool it a few times and see what impact that has. It's taking less heat each time to get it to go open circuit, and then it's taking longer to go back down again. Let's try. So try it again. Let it cool down before I try pressing it in. So clearly what's happened here is the kind of dome part of the membrane has collapsed and it's making a permanent short, and the switch isn't opening again, but hopefully if I can get the dome to come back up a little bit, it should start working. So I'll work on this for a while and let you know how it turns out. I've heated and cooled this a number of times, and as soon as I apply heat now it goes open circuit, but as soon as it cools down it returns back to a closed switch. What I'm going to try doing as a last resort is I'm going to glue a piece of tubing to this area around where the contact part of the switch is, and I'm going to heat it from the other side while applying a vacuum to this side, and then I'll let the whole thing cool down. What I'm trying to do is get this center section to regain its kind of dome shape. It's just gone completely flat and it's kind of caved in, and I've got a feeling there's supposed to be a slight dome there. In fact, when I heat it up I can see it doming up slightly, but then it collapses again as soon as it cools down. But if I can get it to kind of take on a dome shape that's a bit more permanent, get it to cool down in that shape, then it may well start working. I've been working my way around this keyboard trying to resolve the issue of the stuck keys. So this is just basically a simple membrane, and each of the key areas is sitting underneath one of these plungers, and these are kind of plastic welded to the aluminium backing plate. Kind of poor design really. These membranes are not reliable when you use them like this. If you put a lot of pressure at a certain point on these membrane switch panels, then they do tend to fail. These don't even appear to have domes underneath them, so these were kind of destined to fail anyway. But it is what it is, and I need to try and get it to work if I'm going to get this machine working. And what I've been doing is I thought that as it's a kind of plastic material, and if you heat up plastic you should be able to reform it to a certain extent. So what I've been doing is using tin foil to mask off the area I want to heat up. I then use a heat gun to heat up the area. I'm not getting it really hot, I'm just trying to make it fairly soft. I've then got I've got a vacuum pump attached to the underside of my workbench. I use it for various things. In this case I've got it attached through a silicone hose to an old flux dispenser. It's basically a syringe. I've cut the end off the syringe and machined it so it's nice and flat. And what I do is once the membrane's hot, I put this over it, switch on the vacuum pump. This will suck itself down and will also start trying to kind of pull up the area on the switch I'm trying to separate from the backing part of the switch where it's shorted. I leave the vacuum going for maybe 5 minutes until the area's cooled down, and it actually seems to be working. So this is the switch I was having problems with to start with. It was shorted all the time, and now as you can see it's working just fine. I've actually left this overnight since I did this, and it seems to be working without any problems at all. I haven't put the plunger back on yet, but I've been giving this a bit of abuse since I've done it, and it seems now to be working. Unfortunately I found some other switches that are also stuck closed. The one underneath it, for example, the G key is also stuck, or was. I've done that as well, and so I just need to work my way around the keyboard and fix any of the keys that are stuck. To get the keys off, all I'm doing is getting a soldering iron with a wide tip, heating this and just pushing off this section that's been kind of plastic riveted over. And to refit it, all I'll do is push this back through, then use a fine tip soldering iron, push it into the hole, which will then obviously have the plastic post in it, that will cause the switch post to kind of melt and form over the hole, and it will stop it falling out. And then once I've got all these done, hopefully the keyboard will be, don't know how reliable it will be, but hopefully it will be good enough to allow me to carry on with the repair. As I said, I don't know if this is going to be long-term reliable. It seems alright at the moment, but chances are if it's failed once, it's going to fail again. Or it might be a permanent fix. This was never formed upwards to start with. It started life flat, and I think that's part of the problem. And we'll just have to see how it goes. In the meantime, we'll keep our eyes open for a replacement keyboard, but this does at least seem to be getting us to the point where we can continue working on the electronics. I don't think this is the thing that's causing the machine not to start up, because otherwise I'd be able to start it up when I manually short the return key connections on the connector, and that's not working. It's not doing anything, but at least this will make life easier if we can have an actual keyboard attached. I have found another problem with the design of this keyboard, and this key that I've been working on was stuck shut, and it was working. You can see now it's not doing anything. It's not the key this time. This is now this connector. So if I push this flat flex cable and then press the key again, you can see on the meter it's now working. The problem here seems to be there is this hot melt glue on the back edge of the connector, and when it was put on, it seems to have worked its way down into the connector, and it's pushed the connector apart. So this probably works when it's pushed into the keyboard case, because it's pushed like this, because this is fairly close to the edge, but I think that's just fortuitous. I don't think it's supposed to do that, and this is extremely loose, and normally it's fairly tight. If I just gently pull this, you can see it pops straight out, because the glue has actually spread this out. You can kind of see there's a big gap in the contact. You probably can't see it, but I've looked at this under a microscope, and the hot melt glue has splayed this out, and so it's no longer gripping tightly on the contacts on the flat flex cable. So I'm going to crimp this up and try and get it working again, but that's something else to look out for if you're having problems with one of these keyboards. So I'm not really impressed with the design of this. I think it's a very poor design. It may have worked well for a short time, but long term I do not think this keyboard would be particularly reliable. These membrane keys, by the way, they're not that reliable for hundreds of thousands or millions of key presses. They're alright for maybe 10-20,000 or so for keypads that aren't heavily used, but something like a keyboard where it's expected to have millions of key presses is not really a good design choice. I had a look at the connector type used on this, and the back edge of it is actually quite soft. So what you can do is, what I've done here is just very gently ease the contacts back out, but to make it a bit more reliable long term, I've also put some backing onto the end of the flat flex. Most modern flat flexes have a backing on them anyway to stiffen up the end, and it's meant to prevent this sort of issue. So it's just a few layers of good quality hard tape, and that will not only thicken this up but also stiffen it and hopefully make it more reliable. So I'll try plugging this back in and we'll see if it's improved things at all. Okay, so that's plugged in. It's actually quite tight in there now. It doesn't, before it just slid out, and now it's quite tight. You can see I can pick the keyboard up with it. I wouldn't suggest doing that, by the way. But it's now nice and tight in the connector, whereas before it just fell out. And if we look at the multimeter, so whereas before this contact was, the switch was no longer making contact because the flat flex wasn't making contact, you can see now that we are getting the correct resistance value. So nice low resistance values going through the connector, and it seemed reliable. So what I'll do now is refit the plungers, check for any remaining faulty switches, and then hopefully we can start using this. I've operated the key quite a few times now, and it seems to be reliable. So looks like it will be at least a short-term fix. So going through the keyboard, it was clear that there were issues, and the fact that the display was flickering after we pressed the reset button meant that essentially the machine thought there were at least 2 or 3 keys being held down, and none of those were the return keys, so it wasn't trying to go to the part of the boot up code to read the disk. And I'd already tried jumpering this connector. This is the keyboard connector, and looking at the pins in the datasheet, we need to short pins 3 and 15, which are the ones I was shorting, but it didn't do anything, it just flickered again. And looking around, unfortunately I didn't get it on camera. I had the main board tipped back up, and I found that the cable that runs between the main board and the floppy disks, it had been pulled out at some point, and where if you're familiar with how the IDT connectors work, they're kind of little fingers that push through the insulation when you crimp the ribbon cable onto the connector, and it had been pulled out and it looked very loose, and it was just sort of flapping about. So I cut the end 1/2 inch off the cable, re-crimped a new connector, and we can now give that another try. Basically there weren't all these signals going through to the floppy disks. A few were going through and the power seemed to be getting there, but the reset and the step out and home signals didn't seem to be making it through to the floppy drives. So we'll try it again. This is on pin 3. We'll try shorting this out to pin 15. Okay, and it is now trying to boot from floppy disk. It's saying boot error. I'll just press reset so it doesn't keep destroying it, but it's saying boot error. And if we now take out the floppy disk and see if that error message changes, we should be able to tell if it's actually reading anything from the disk, or it's just not capable of accessing the drive. And now it's doing something different. It's still saying boot error, but it's taking much longer. So it does actually look like it's capable of reading at least some data from the disk. So okay, that really is it for this video now. In the next one we'll start looking at what's coming out of the drive. I do have a boot disk, but I've only got the one, so I don't want to put it in until I'm fairly sure it's not going to be destroyed. So we'll start by putting a scope on the data output of the drive and see if anything sensible is coming out of it. If it is, we'll try actually booting from a disk. The keyboard's still not working properly yet, so that's why I don't have it plugged in. I've got some more keys that still are showing a short circuit. I've got a feeling the keyboard might still be a problem for this machine. But at least we are making some progress, and hopefully you're finding this of some interest.